Hey, welcome to day one of Intro to Triangles. Today we're going to look at applying triangle sum properties and classifying triangles by side lengths and angle measurements. Now, a lot of this stuff about classifying triangles should hopefully be reviewed from middle school. If you don't remember this, that you may want to look back at some old material that you have. Now, classifying triangles by the side lengths. You're going to look at how many congruent sides you have. If none of the sides are congruent, so all three of them are different lengths, you have a scalene triangle. If you have at least two sides that are congruent, then you have an isosceles triangle. And if all three sides of a triangle are congruent, you will have an equilateral triangle. Now, something that you might notice, wait, if all three sides are congruent, doesn't that mean that at least two sides are congruent? Yes. Yes, it does. Now we're going to take a look at classifying triangles by angle measurements. Now, an easy way to remember how to classify triangles by their angle measurements is to look at the biggest angle of the triangle, because every triangle is going to have two acute angles. It's just a matter of what that biggest angle is. If the largest angle is an acute angle, then you have an acute triangle. If the biggest angle is a right angle, then you have a right triangle. If the biggest angle is an obtuse angle, then you have an obtuse triangle. This last term is something that you might not have seen before and might have a little bit of difficulty pronouncing. Equiangular. An equiangular triangle is one where all three angles are congruent. That means that each angle is going to be 60 degrees. Now, I want you to take a look at these three triangles that we have here and see if you can classify them by their side lengths and angle measurements. For this first one, you may have noticed that we have three 60-degree angles. All of these are the same, so it's equiangular. We also have three sides that are all the same. They're all 8.6 in length. That means that this is an equilateral and equiangular triangle. Next, we have two side lengths that are 2.5. The third one is different, so this is going to be an isosceles triangle. Looking at the biggest angle, its measurement is 128 degrees. That is greater than 90, so it's an obtuse angle, which means we have an obtuse triangle. For this third example, your teacher will go over it with you in class. Remember to look at the biggest angle and what the relationship between the side lengths would be. The next thing we have today is the triangle sum theorem. The triangle sum theorem basically just says that all three angles inside a triangle are going to add up to 180. So if you're looking at the angles in a triangle, what do they need to add up to? 180. For example 2, we've got three marked angles, 2x plus 4, 3x minus 5, and 2x minus 1. See if you can set up an equation to find the measure of each angle and the value of x. So, if you set this up, your equation should look something like this. Notice that we've added all three angles together, 2x plus 4, plus 3x minus 5, plus 2x minus 1, and set it equal to 180. When you go through to solve this, you should combine your like terms to get 7x minus 2 equals 180. Add 2 to both sides, so now 7x equals 182. And then divide by 7 to get that x is 26. Now, the corollary to the triangle sum theorem is that the acute angles of a right triangle are complementary. This happens because if all three angles add up to 180 and one of them is 90, so you have to subtract 90 from 180, you're left with 90 degrees that can account for the other two angles. See if you can use this information to set up an equation for example 3. Don't solve it yet, we'll talk about how to do that together. So if you got 2x plus x minus 6 equals 90, great job, give yourself a pat on the back. Another way you could do this would be to add up all three angles and set it equal to 180, but you should only do this if you don't remember the corollary. When we go through and solve this, we combine our like terms, add 6 to both sides, and divide by 3 to get x equals 32. If you thought we were done with this problem, you did not read very carefully. We need to find the measures of the acute angles, so let's plug x in. 2 times 32 gives us 64 degrees for this angle up here. 32 minus 6 gives us 26 degrees for this angle down here. Something you should check is to make sure that these angles actually add up to 90. If you add 64 and 26 together, sure enough, they do add up to 90 degrees. Our next theorem is the exterior angle theorem. The exterior angle theorem says that the measure of an exterior angle, that means one on the outside of the triangle created by extending one of the sides, is equal to the sum of the two non-adjacent interior angles. So here that would be the measures of angles A and B should add up to give you the measure of angle 1. This is kind of a weird consequence of the way that linear pairs work and the fact that the three angles in a triangle also add up to 180. Now, using this theorem, see if you can set up an equation for example 4. You should have gotten x plus 70, so adding angle J and angle L together equals 2x minus 5, the measure of angle JKM. When we go through to solve this, we end up with 75 for x. Since we want to find the measure of angle JKM, we need to plug this into 2x minus 5, and we get that the measure of this angle has to be 145 degrees. Looking at example 5, we want to find the measure of angle 1. That's this angle on the inside here. See if you can set up an equation using the exterior angle theorem and then solve it and find angle 1 based on the information that you gather. If we add these two interior angles, 3x and 40, we should get 5x minus 10. When you go through to solve for x, you end up with 25. Now we have to plug this into 5x minus 10 to find the measure of the exterior angle, and then use the fact that we have a linear pair to find angle 1. If we plug this in, we get 5 times 25 minus 10 equals 115 for this exterior angle. And so the angle it forms a linear pair with, they need to add up to 180. If you subtract 115 from 180, you are left with 65 degrees for the measure of angle 1. You may need to rewind and watch this example again if that went a little quickly for you. This last example is bringing in some information from the last unit. You need to remember how to use the distance formula to find the length between 2 points, and if we want to figure out if we have a right triangle, we need to figure out if any of these lines meet at right angles. I wonder what we need to do to find out if two lines are perpendicular on a graph. See if you can think through this on your own. Give it a solid attempt. Your teacher will go over it in more detail when you get to class. Have a great day.